Hi, my name is Henry Webster. This is my final project for Intro to Computer Science 110, Professor Wellman's class. I've chosen to do the coin toss simulation. So we're going to jump right in here. So the first thing that the program does is it imports a couple of modules, or a couple of functions from modules. So it imports random from the random module and factorial from the math module. And I import factorial because it just seems a little redundant to have to write my own factorial function when it's something that's built into Python's source code. So I make it a little easier and I just import it. Alright, next thing that happens, it's not the next thing that initializes, but it's the first thing the user sees. So in the main function calling section, I've got main and run sim. So main is the first thing that's called. The last thing to be defined in the list, or in the block of, rather in the Python file, but then it's called right after, and it greets the user with like a welcome message, and has a simple sort of UI where input is handled. It lets the user know those four commands right there: full, light, clear, and quit and exit, which are functionally the same, quit and exit. So the user can type in any one of these on a line that prompts them to type in input, and it'll do something. Because I didn't want this program to just be a program that you run and it does one thing automatically. I wanted it to have a little bit of flexibility. So if you type in full, it'll run a full coin tossing simulation. So the full number of iterations is mandated by the project rubric. If you type in light, it runs a small version of a full sim, wherein it has far less iterations, far less cases, so to speak, tables to print. It takes like practically no time at all, and it's for the sake of running through the program with a very light simulation so that it doesn't take forever to do simple bug fixing or whatever. Clear deletes everything printed to the text file called outcomeprobabilities.txt, and it calls a method that I'll talk about later, or sorry, a function, not a method. That's C#. It calls clearFile, a function that I use a few of these for like file manipulation. I'll talk about that in one of these sections. Quit and exit they do the same thing. They call clearFile, so they do the same thing as clear, and then they break the main loop, wherein it's like a while loop. It uses a boolean called quitting, and if quitting is true, it clears the file and then breaks the loop, and that loop is in this method, or this function, the main function. Also, if the user enters a command to run a simulation, full or light, it calls runSim and passes the arguments simnum and input to it. So what runSim does is it takes the arguments simnum and simtype being what's taken into the function here, but what's passed into it from main is input. So what it does is it checks to see if the user wants to run a full or light simulation, and runs the respective simulation by calling writeFile for every case of that simulation. And then it passes to writeFile n, which is the number of tosses, m, the multiplier for that, like the number of experiments of those tosses, and the probability of heads. It uses these nested for loops, as you can see right here, to iterate through the simulation. And then also, right here, it's got these print statements, and those print after every one iteration of each of these for loops is completed. So when, say, the case 5 tosses times 1,000, so 5,000 tosses with a probability of 0.5, when that table is printed, that case is done, it'll print you a little message right here to let you know that that's done. And it'll go through, in a full simulation, it'll go through all 4 of these. Like you'll see 4 of these messages before it prints one of these, and so on and so forth before it prints one of these, which denotes that the case is done. Also, oh yeah, and it's just so that the user can see the actual progress of the simulation, because a full simulation can take a really long time, and it's kind of hard to tell whether or not it's working if the Python shell is just sitting there blank. So, runSim, the other thing it does is that it writes a header to the text file with the number of the simulation, so that you can, because this program, the way I've written it, it accounts for you being able to run multiple simulations in one text file without clearing it every time. And it'll number each simulation and also put next to it the type of simulation, whether it be full or light. So you can look in the search file with Control F and search for the simulation number and find it. It'll also print the status updates. It'll also print status updates of the simulation in the Python shell. Before it begins, it'll print please wait, and then it'll print all these loading messages, and then when it's done, it prints an all done to let you know. So next we're going to move to file writing and input output. So the functions we've got here are write file, open file, close file, and clear file. First three we'll talk about are the really short, simple ones. Open, close, and clear file. These are just ease of use functions that I've defined because I have to open the file and close the file and clear the file in more than one place, but I don't want to have to write, say, all that in the multiple places that I want to do that. So I simplify it by putting all that in one simple function. This close file actually is super simple. It's just one line, but I still wanted to put it in there for the sake of consistency. And they all manipulate the same file because there's only one to be dealt with in this program, which is outcome probabilities.txt. So write file is called by runSim, and it takes the arguments n, m, and probability heads. It doesn't use them because it just passes them on to probability or prob, coin toss, q tosses, z times, which we'll talk about in the next section. And also, before starting the simulation of a case, write file prints a table header to the file consisting of the case information. So it'll print n, so the number of tosses, the probability of landing on heads for this case, and the number of experiments to be run. And then it'll also print column headers for the rest of the table that's about to be printed out in a for loop right here, so that it neatly organizes the columns so that you can see what they actually are when it prints out in the file. So then, this is the for loop I was just talking about. Also, before this for loop, it defines the sum of simulated probability and sum of predicted probability, which are just accumulators, and those will later be used right here. Actually, they're used right there. They're incremented right there to then be printed out later at the end of the table to show you the sum of the simulated probability and the predicted probability, as is mandated by the rubric. So anyway, this for loop begins, and it counts down from n to -1. Oh geez, I wrote this this bullet point a little wonky, so sorry about that. But anyway, this loop counts from n being the number of tosses down to -1 in steps of -1, meaning if the n, the number of tosses, is 10, it'll then count 9, 8, 7 until it gets to 0. And then it uses that in some of the calculation stuff and printing stuff in this function to this would be the number of heads, and then it would calculate the probability, say, for 10 heads and 0 tails, 10 or 9 heads and 1 tails, and so on and so forth. So that's why that's how that for loop works. And then very importantly right here is that line of code, which I talk about right here. It's the most important line in that for loop because write file still isn't actually simulating the coin tossing just yet. It's just passing more arguments into the part where the actual math, or the actual number generation is done. So it passes those arguments to prob, coin toss, q tosses, z times in the tossing simulation section of the code. So in tossing simulation, we've got coin toss, q tosses, z times, and probability, coin toss, q tosses, z times. It's a mouthful. So the first one we'll talk about them from the simplest to the most complex. And it's kind of like I guess we're going from the bottom of the hierarchy to the top in terms of the way these functions call each other. And we'll start with coin toss, which is literally just, it tosses a coin, figuratively speaking. It's not a real coin, it's a program. So it uses the random function and one conditional statement right here to determine if the coin landed on heads or tails. Heads being 1, tails being 0. Tails and then it'll return that value to coin toss Q tosses. So coin toss Q tosses Q times and returns heads. This function calls coin toss Q times, as you can see here. That's why it's called coin toss Q tosses. And it then accumulates the result of coin toss, which is either 1 or 0, to the accumulator number of heads, because it already knows what the total number of tosses is with Q, and so do the functions that are before it that call it in the hierarchy. All it needs to know is the number of heads out of the number of these tosses to then calculate the probability of that occurrence. So what it does is if Q is 10, then it'll call coin toss 10 times and then add the number of times the coin landed on heads out of those 10 tosses to num heads, and return num heads to coin toss Q tosses Z times. And this thing creates an empty dictionary, DCT, I'll just call it the dictionary, and it creates a key for every possible number of heads that could be tossed out of Q tosses, as you can see right here. And what that'll do is it'll make the dictionary values if Q tosses was 0 heads, these two functions here and then here would pass a value back up, in which out of one iteration of 10 tosses, it returns 0 heads, then the 0 key value in this dictionary would be 1. And then it just keeps incrementing those for Z times, because you've got maybe 10 tosses, but you got to multiply it by 1,000, so overall you're going to have this many tosses. And then it'll add num heads from coin toss Q tosses for every iteration of Z. So what it does is creates a dictionary of the occurrences of every possible num heads out of Q tosses for Z total experiments. Experiments being the number of times the function repeats coin toss Q tosses. And it does that with this code right here. So then probability of coin toss Q tosses Z times finds the probabilities of all the items in that dictionary by dividing each key value pair by Z, and then it'll return a number that expresses the probability of that occurrence. So the occurrence of 0 heads and 100,000 tosses, it'd be a pretty high number in the dictionary defined back here, but then you divide it by Z and it'll be like a decimal value, and it returns that dictionary to the stuff in write file that then writes it to the table. Write file also uses a couple of these functions here in probability calculation. Uses which includes eval first term, which just evaluates the first term of the equation that is set up in theoretical probability. So that's exactly what it does. There's all this code right here. Basically what it's doing is, where did I write that down? This part, or this function, is doing the math for times probability heads, number of heads, times 1 minus probability heads to the number of tails. So this is the equation for theoretical probability, which is set up in the theoretical probability function. And eval first term literally just does the math for this part right here, to make it a little simpler by using the factorial method. And I commented out this code to show that that's how you would do it if you, or that's how you could do it in multiple lines to kind of make it easier to read, but then I figured I could actually just condense it all into one line. So theoretical probability calculates the probability of any number of heads, number of tails pairing, and then returns that to the write file thing for it to print out. And so there you go. That's the that's my presentation for my coin tossing final project, and I hope you enjoyed it. Thanks a lot.